What can happen if we cement a volcano's lava? The volcano erupts, hot lava flows down the mountain, the smoke thickens, people panic, breaking news spreads on social media, and someone comments, why not just cement the top so it doesn't erupt? Cement the top of the volcano? It sounds like a simple solution. Just cover it and the problem is solved. But is it really that easy? Can a volcano be stopped just by using cement? Let's find out. Occasionally, volcanoes such as my own volcano in Albay produce lava through what are called effusive eruptions. These eruptions are relatively gentle and not sudden or extremely violent. During this type of eruption, lava slowly flows from the summit of the volcano down its slopes. This happens when magma rises from beneath the Earth's surface and finds a clear path to escape. Even though these eruptions are less explosive, they are still dangerous. Lava flows and small rocks can be ejected around the crater, putting nearby communities at risk. Fortunately, authorities usually have enough time to evacuate people because the eruption develops gradually rather than instantly. The most dangerous type of eruption is an explosive eruption. In this case, thick, sticky magma traps volcanic gases beneath the surface, allowing pressure to build up. When the pressure becomes too great, the volcano erupts violently. Explosive eruptions can produce pyroclastic density currents, which can travel at speeds of up to 100 kilometers per hour. These scorching clouds of gas, ash, and rock are among the deadliest volcanic hazards because they can burn and destroy everything in their path. Heavy ashfall is another major danger. Ash can accumulate on rooftops, causing them to collapse, while also creating serious breathing problems. Another hazard is lahar, a mixture of volcanic ash, rocks, and rainwater that usually forms during heavy rainfall after an eruption. Lahars can bury homes, roads, and bridges. Although scientists cannot predict the exact date and time of a volcanic eruption, volcanoes usually show warning signs before erupting. Now, even if it sounds funny, could cementing a volcano actually work? My own volcano stands more than 2,463 meters tall and is an active stratovolcano. Suppose we tried to cover its crater with a 10-meter thick layer of concrete over an opening about 200 meters wide. This would require approximately 314,000 cubic meters of concrete. Since each cubic meter typically requires 7 to 8 bags of 40-kilogram cement, more than 2.3 million bags of cement would be needed. If each bag costs around 220 pesos, the cement alone would cost roughly 506 million pesos. However, cement is only one component of concrete. We would also need sand, gravel, water, reinforcing steel, transportation, heavy equipment, helicopters, or specialized delivery systems to reach the summit, and thousands of construction workers and engineers. In large construction projects, cement usually accounts for only 25% to 35% of the total cost. Factoring in all expenses, the total project could easily cost 1.5 to 2 billion pesos just to cover the crater, and that doesn't even address the deeper volcanic system. Even so, compared to the Philippines' flood control projects worth over 545 billion pesos, someone might ask, wouldn't it be better to cement the volcano instead? Unfortunately, no. Covering the crater with thick concrete would not stop magma from rising from deep within the earth. Magma reaches temperatures between 700 degrees Celsius and over 1,200 degrees Celsius and is driven upward by enormous pressure. The magma would not simply obey a concrete barrier. If pressure continues to build beneath the volcano, it will search for weaker areas where it can escape, or it may simply break through the concrete itself. Magma also cannot simply flow back underground. It continuously rises because of forces deep within the Earth's crust. Unlike water, it cannot simply be stopped by placing a lid on top. Volcanoes also constantly release volcanic gases, such as sulfur dioxide, carbon dioxide, and water vapor. Concrete cannot permanently contain these gases. They would eventually escape through cracks or new openings, creating dangerous air quality even far from the volcano. Even worse, sealing the crater could trap even more heat and pressure underground. If that pressure is eventually released, the eruption could become even more violent, producing stronger explosions, wider ashfall, larger rocks, and hotter gas clouds. In other words, covering the crater could actually make an eruption more dangerous instead of preventing it. What if we filled the entire volcano with concrete instead? Besides the enormous cost and the nearly impossible engineering challenge, fresh concrete cannot properly cure inside an active volcano. The extreme temperatures would cause it to crack, weaken, or fail long before it became strong. Even if the concrete somehow hardened, it still wouldn't stop the volcano. Magma comes from deep within the earth, not just from inside the mountain itself. Blocking one pathway would simply force magma to find another route. Instead of erupting through the main crater, the volcano could develop new vents on its sides, potentially creating new hazards closer to nearby communities. Today, humanity does not have the technology to stop or control an active volcano. Instead, volcanologists focus on monitoring earthquakes, ground deformation, and volcanic gas emissions to detect signs of an impending eruption. When activity increases, authorities raise alert levels and evacuate people from danger zones. The best solution is not to cement or block a volcano. The best solution is early hazard detection, proper preparation, and avoiding dangerous areas. We may not be able to stop a volcano, but through science, monitoring, and preparedness, we can greatly reduce the risks it poses.